Greetings, junior scientists, and citizens of this great, big, weird, wild, and wonderful world in which we live. As always, I am your humble science communicator, the Great Orbax, here for a special edition of our Stargazing Guide. In the evening of November 18th into the early hours of the morning of the 19th, we're going to have the opportunity to see the longest partial lunar eclipse in this century. And everybody in North America is going to be able to see it. So what exactly is a lunar eclipse? You're likely familiar with a solar eclipse. Now, this occurs when the moon passes between the Earth and the sun. But what's a lunar eclipse? Well, a lunar eclipse occurs when the moon actually falls into the Earth's shadow. But the moon appears to line up with the Earth like this twice a month, during new moon and full moon. So why don't we have eclipses twice a month then? Well, it's actually a little more complicated than that. The plane of the moon's orbit around the Earth is actually tilted with respect to the plane of the Earth's orbit around the sun. But here's the thing, the moon's orbit stays fixed with respect to the stars, meaning that tilt actually changes with respect to the Earth. And twice a year, it actually lines up in such a way that the moon passes through the Earth's shadow, and that is when we have a lunar eclipse. As the moon passes through the Earth's shadow, it'll still be visible, and it might even have a red tinge to it. So why is that? As light passes through the Earth's atmosphere, it's scattered, meaning that shorter wavelengths like blue light are actually diverted away from the moon, whereas longer wavelengths like red light are what pass through and illuminate the moon. As a matter of fact, if you happen to be standing on the moon during the lunar eclipse, you'd actually be bathed in a red glow and see a red ring emanating from around the Earth, which is all that remains of the light escaping Earth's atmosphere, of all the sunrises and sunsets that are taking place along the edge of the Earth. November's full moon is known as the Beaver Moon, named from folklore as the beavers urgently prepare for the winter to come. It's also known as the Frosty Moon and the Oak Moon. But back to our lunar eclipse. The moon will start by passing into the penumbra, the part of the Earth's shadow where the sun is only partially covered by the Earth. At this point, you won't really be able to see any changes to the moon with the naked eye. Around 2 a.m. Eastern Time, it will pass into the darkest part of the Earth's shadow, known as the umbra. This is where the Earth completely obscures the sun from the moon. At the moment of greatest eclipse, around 4 a.m. Eastern Time, 99.1% of the moon will be entirely within the umbra. This will be visible from all of North America, as well as some parts of South America, Polynesia, Eastern Australia, and Northeastern Asia. By 6 a.m., the moon will be back to normal viewing. This is the longest partial lunar eclipse that will take place this century, with a duration of 3 hours, 28 minutes, and 23 seconds. So if you get the opportunity, I suggest you take the chance and look up. Don't forget to have a science-tastic day! Special thanks to Royal City Science's own planetary geochemist, Dr. Glynis Perrett, for her help preparing our stargazing guide.